Now let's talk a little bit about volume. Write a formula for the volume of each three-dimensional solid using the given variable lengths, like we have side lengths, lengths, widths, heights, and so on. So let's back this up just a little bit. Remember that we had talked about area and perimeter as measurements that are associated with shapes in geometry. Perimeter was associated with a length, it's one-dimensional. It's how far you go around your shape, right? If you take each one of these segments, line these things up, you just make a big old long stick, you're measuring in its length, and it's in linear units like inches, feet, centimeters, and so on. Area it's a two-dimensional kind of measurement, and we're basically asking how many squares it takes to fill something up. We're tiling that shape. It's measured in square inches, square feet. It is a two-dimensional kind of measurement. Okay, volume, on the other hand, is a three-dimensional kind of measurement. Volume. It's about capacity or space. And again, it's 3D. Now, instead of being about like sticks, being about tiles, it's about cubes. The question about volume is, how many of these cubes does it take to fill something up? All right, so, something like this. I put one of these in here, maybe put another one of these in there, and so on. And I'm just trying to figure out how many it takes to fill this thing up, and so on, right? That's the question about volume. So it is how many cubes to fill. Again, three-dimensional kind of measurement associated with shapes. And as three-dimensional, it's going to be in inches cubed, feet cubed, miles cubed. You get the picture, right? Okay. So now let's look at each one of these various formula for cubes, rectangular prisms, all of these different kinds of shapes. Okay, first one up, most basic one is the volume of a cube. Volume of a cube is side times side times side. And the more compact way of writing that, of course, is just side cubed. You just take your side length, whatever it is, 3, 7, 12, whatever, and raise it to the third power. You're done. And then don't forget your units. Okay, rectangular prism. We're asking how many of these cubes it takes to fill this thing up, and it is the classic length times width times height. All right, now as far as this formula goes, there is a way to kind of represent any kind of prism, not just rectangular prism, but also the triangular prism or whatever shape that base is that you want. In this case, of course, we've got the shape of a rectangle. Here we have the shape of a triangle for that prism. And the more general way to represent this is we take the length times the width, which is the base, and we say that it has an area of capital letter B, which is the area of the base. Great. So you take the area of the base and you multiply it times the height. Hey, well, what is the area of the base? It's length times width. So either one of those would be fine. So I could write this as a big B times an H if I wanted to. Okay, let's move on to a rectangular pyramid. Pyramid, all of its lateral faces here are triangles, whereas these were rectangles, and the base shape down here is a rectangle. Sometimes it is just a complete square, but this one just a rectangle. So it turns out that this shape here, if it has the same length, the same width, and the same height as this rectangular prism, it is exactly 1/3 the volume of this rectangular prism. So its volume is 1/3 times the length times the width times the height. And as we talked about before, I could take this length and this width and I can replace it with big B. And hey, what is big B? Big B is the area of the base, in which case it would be, this guy right down here. All right, and let's see, we got a couple more. Triangular prism. Triangular prism, the shape of the base down here, or up here even, is just a triangle, and we got to find its area, which is 1/2 base times height. And hey, you see there's a lowercase h and there's the uppercase h. This uppercase h, this capital H, it's not common. It's just that it's totally confusing to have two different kinds of heights. You have a height of the base down here, the triangle, and then you have a separate height for the actual prism. So how are you supposed to differentiate between those two? I chose to use a lowercase and a capital letter h. So it is 1/2 base times height. What that just gave me is the area of the base, just as we talked about previous questions, area of the base there. And then you multiply that times its height. Just like that. When you think of the formula of a triangular prism in this sense, where it is this capital letter B, area of the base, multiplied times the height, it is essentially the same kind of formula as that rectangular prism. All right, and the last one here, triangular pyramid. So triangular pyramid is very similar to this rectangular pyramid, and that we need a third. 1/3 of basically what we have like right here. So its formula is going to look like this. 1/3 of the 1/2 base height, there's the area of the triangular base, and then multiplied times the height of that whole entire pyramid. And if y'all wanted to, you could take this 1/2 base times height, which again is the area of the base. It's this guy that's down there. Boopy. That's an ugly B. That's a better B. Hey, this one over here, that is also a B. All right. Now, how does that apply to the next questions? Well, it's fairly straightforward. On 34 through 37, use the formulae above to solve each problem. On 34, the side length of a cube. It tells you there's a cube. Is 2/3 centimeters. What's the volume of that cube? So it's a pretty straightforward application of this formula we talked about for the cube. The only complication is the fact that you have a fraction, and I'm going to suggest keeping it as a fraction. Don't put that in to the calculator as some kind of decimal. And let's say, for example, I don't want to use the numbers that we have here, so I will use, I don't know, 4/3. Let's say, well, okay, fifths. And if you're going to multiply that, or not multiply, raise that to the third power, for example, it's the same thing as the top to the third power and the bottom to the third power, just saying, all right? So just apply that same kind of logic to the actual number that you have on 34. On 35, base of rectangular prism measures 2.3 centimeters by 4.1 inches. Did I say centimeters? Probably did. If the volume of the prism measures 9.43 inches cubed, what's the height of the prism? All right, so let me call your attention to this. Notice that these are decimal numbers, okay? So we would probably keep our numbers as decimals, and our final answer will be a decimal number. All right, back over here where it was a fraction, keep it as a fraction, and your answer should be a nice compact little fraction when you're done. This one, rectangular prism, it's right here, of course, and this is one of those where you have the answer. It already tells you your volume, so you may have to work backwards just a little bit there. Okay, 36 and 37, very straightforward applications. You got to pick out the right formula, though. What's the volume of this solid? So I'm going to go, hey, look, this looks like a pyramid. We got triangular faces going around here, so it's a pyramid. And then the base down here, it's a 6x7. Oh, it's so close to being a square, but it's not. It's a rectangular pyramid. So kind of a straightforward application of that formula there. And then finally, 37, we've got a, hey, don't get it confused. Sure, this has triangles, but those are the bases. Bases, remember, in geometry, in math, you don't have to be sitting on your base like this one. That is the base. It is a right triangle, and so it is a triangular prism. This one is more like a wedge shape or a doorstop, right? So it's an application of this guy right here. So be careful. If this is the base, this blue thing that is colored in here is the base, then the height is not 24. The height is not 25. The height is the distance between these two triangular faces, which is going to be the number 8. Hey, I'm just going to highlight there. That is the height of the thing. All right, so that should wrap up volume of these kind of shapes. And these kind of shapes where, notice that there's no kind of curves in these shapes. These are all polygons. That's different from the ones that are coming up where we have nice smooth curves on these. These type of shapes have a special name, and it's called a polyhedron. Polyhedron. So the word poly means many, and it's associated with like polygons. So your faces are polygons. This is the three-dimensional version of it. When you have a singular one, it's called a polyhedron. If you have more than one, it's called polyhedra. Just so you know.